Hey, so have you ever tried to build a CLI in C and you were annoyed how you had to implement your own manual command line argument parsing? Were you turned away after seeing how difficult it really is in reality? Well, I have the solution for you. It's a single header C99 library I wrote in C. It's embedded friendly, so no malloc, no free calls. It doesn't use too many macros. It uses some macros for quality of life and stuff, but it's pretty minimal with the macro usage. And you can do some pretty cool stuff. Like it has recursive subcommand parsing. It has variadic arguments, so you could do like with a package manager, you could do sudo apt install git svn, a bunch of different packages. You can install many packages at once, and you do that by passing in many package names to a package manager, so that's a bunch of variadic arguments. It supports parsing arguments of different data types, so you can parse arguments that are unsigned 32-bit integers, unsigned 8-bit integers, signed 64-bit integers, etc., etc. And it supports all of this with bounds checking in the library. And I thought I'd share this because I saw a video, I'll put it up on the screen now, and it was a guy talking about a library he wrote in C for argument parsing. And I was like, hey, this video is actually doing quite well. Let me make a video about mine, which I think is also something people should know about. And yeah, that's why you're here now too, so welcome, hi. Now, how do we actually use this library? Well, it's quite simple. First, you want to download the library. You can do this however you want, but the easiest way to do so would be to navigate over to the library. Make sure you're on the main branch. There's a dev branch, but that's for development, so stay away from that. If you're a contributor, though, then you want to add code to the dev branch after reading contributing.md. But what you want to do is click on apic.h. You want to download, so you want to download it here. And then once you have it downloaded, you just include it in your C file. So let me go ahead and download it. I'm going to put it in, so coding, C, and APIC tutorial. So, okay, I have it downloaded, and what you do is make sure you have it downloaded, yep. So here it is, and you create your C file. So normally you'd want to break this up into many C files, but since this is just a tutorial, I'm going to do everything in a main.c. So, first off, you want to include the header file. And if this is where you want the translation unit to be, or the implementation unit, or however you like to call it, you want to do define APIC impl. What this does is it takes all the definitions of the functions in the header file and it pastes them in here too. You only want to do this in one of your C files, so choose which one you want to do it in. You can include this as many times as you want to, but you can only define this once. And then if you're not using this in an embedded environment, I also recommend defining APIC OS STD. This will give you functions for things like printing usage that is automatically generated by the library, and yeah, just useful. So now I'm going to create my main function, and I'm actually going to take in int arg c and const char const arg v. And I'm going to create a function that being parse arguments, and it's not going to return any failures. If the argument parsing fails, since this is the first thing you do in your program, this is usually where it's okay to just have exit calls. So I'm going to create an arg struct, and I'm going to say args parse, and I'm going to put this here, and since this is in the C file, it's kind of just a private function, I'll mark it as static. Now I'll create my arg struct, so args like that, and what do we want in here? For example, we could have a message, sure. And this could be a required argument. And then we could have, I don't know, a colored flag to color the message. And for this, I'm going to include stdint, std bool, just so we have a bunch of these types and stuff defined. Okay, so here's our arg struct, and what I'm going to do is I'm going to have the user pass in argc and argv, and I'm just going to have a little line of code up here that says if argc is equal to 0, I'm going to exit failure. In my own code, I do this go-to cleanup pattern, which I'll talk about in a future video, so stay tuned for that. But for now, just to keep the tutorial simple, I'm going to do it kind of the old-fashioned way. I also need stdlib.h for the exit failure and exit success definitions, and I should put return exit success down here. And then what I'm going to do is I'm going to create my arg struct, and I'm going to 0 initialize it. This means everything is initialized to its 0 state, so pointers will be null pointers and booleans will be false, and integers will be 0, floats will be 0, etc. And then what I'm going to do is I'm going to create the parser. So I'm going to do APIC parser, and these cannot be const, and the reason why is because to avoid using malloc and free, I actually exploit what's already here. So I basically do in-place memory operations. And then what I have to do is have my APIC, or not yet. So first, I'm going to just put this in here. I'm going to say, and actually I need to wrap this in a macro just so I don't mess with any internal stuff. So APIC parser. And then what I need to do is I need to configure this. So skip failed optional args. What this does is if an optional argument is filled with invalid data, it just skips it. So like for example, if your program expects 3 optional arguments, for example, a string, an integer, and a string, if the user of your program passes in a string and a string, the integer argument will fail to parse. But since you set this to true, it won't matter. The integer argument will just act like it was never targeted. So only the string and the string arguments will get parsed. It's probably a good idea to leave that false, though, for most programs. There's also the but. This is how you add like subcommands and variadics and stuff. For most parsers, you can just leave this as is, which is just the none but, which is basically where this is the end of all parsing. This parser is the end parser, so that's fine. There's also target args and target flags. So I'm going to do target flags, and I'm going to set this to APIC target flag, or flag target array, APIC array, and what I need to do is I need to pass in an array of flag targets. So I'm going to create that array up here, APIC flag target flags, and I'll just call it, just target flags, or parser flags rather. I will say one disadvantage of this library being written in C is you should be careful about how you name your variables just to keep track of things in your head. So yeah. And what I'm going to do here is I'm going to pass in parser flags, and I'm going to define a macro called ArrayLen and pass in parser flags there too. And ArrayLen is just going to be a macro that gets the length of an array. So you don't need to, if you're not familiar with C's style of getting the length of something, you don't have to worry about what I'm typing here. Just know that this array returns the count of elements in this macro returns the count of elements in an array. So that's all you have to worry about if you don't know what I'm writing here. And what I'm going to do here is pass that in. Good. I'm also going to go ahead and return args down here. And then what I need to do is I need to define my parser flags, but before that I'm also going to go ahead and define some of the other boilerplate. So first off, you need to shift argc up and shift down argv, so shift forward argv, and the reason why is the first argument passed to a CLI program is almost always going to be the program name, so basically what you typed to execute the program. So what I'm going to do is I'm going to do argc minus minus to decrement argc by 1. I'm going to do argv plus plus to increment argv's pointer by 1. So now the 0th element is the 1th element. I'm also going to, before doing that, I'm going to mark down what that executable argument is. So I'm going to say is equal to argv 0. And then I'm also going to define down here, there's some more things you want to say, and that is APIC parser construct hierarchy. And what this does is if you have subcommands and stuff in your parser, this will set them all up and set up pointers to the parent parsers so parsing can continue properly and stuff, because there's also a feature in APIC where you can have shared flags, so like the help flag is shared among child parsers and stuff, and you can configure all of that. And then I also want to say if this is a debug build, so if not defined end debug. So for context, in C projects, when your build is a release build, there's a macro that will usually be defined called end debug. Your build system, you usually set this up in your build system to be defined, but yeah, you define end debug, and that means it's a release build. So if end debug is not defined, then I want to insert some code here. And that code is const APIC parser validity vd APIC parser check validity, and this will just make sure flags don't have clashing names or anything like that, and it does this at runtime. And this is why you only put this in a debug build, is because this can actually be somewhat computationally heavy, not too computationally heavy, but somewhat computationally heavy. And what I want to do here is I'm going to print this. And for that, I need to have stdio.h, which is where printf and fprintf are defined, and all the other cousin functions. So I'm going to print to stderr, which is where errors, warnings, and log messages that aren't info logs should be printed to. And then I'm going to say runtime parser validity check failed, and I'm going to put the reason why, which I believe I can do with APIC parser validity to cstrt, yup, and I just pass vd in there. And then I need to exit, so exit failure, just like that. And that's that boilerplate done. I also have to define these flags. So I'll do APIC flag target, and I gotta give this the flag target. So the flag target in APIC is essentially a value that points to where data should be stored and how it should be stored. So I'll just create this so you can see. APIC flag value target this time. And I'll say flag value target help. APIC flag value target. And since help is just a Boolean flag, meaning you are simply doing my app help and not my app help equals 1 or something like that, you can do the switch type. The non-switch type is what takes in data. So if you want a flag that takes in data, you do the non-switch type, and that gives you some more options like, oh, I want this to be an integer, etc. And I'll show you that too. So I'll do the switch type, and this simply just takes in a Boolean. So I'll create a Boolean up here called help, and by default I'll just set it to false. And now I want to configure this flag. So I'm going to type in here flag value target help to reference this variable. Then I'm going to put curly braces, and I'm going to define all the information for this flag. So that will look something like, first off, I want to define the name of the flag, which is just help, and optionally, so APIC lets you define, you can define either the short or long name of the flag or both. So APIC lets you choose whether you want your flag to only be short named, only be long named, or both. So I need to use an APIC stir slice, and APIC provides a macro called APIC stir slice literal, so you can create a stir slice from a literal string, and this has runtime benefits since a literal string stir length can be calculated at compile time with the size of directive or whatever you want to call it. So yeah, and I'm just gonna call it help, and then the name short will be a single character, so help, so H, just like that. And then you have some other options in here, and I'll go through these two. They're pretty useful. So first off, we have the description, so you want to add that for usage and stuff. And sorry if I sound weird, guys. I'm a little sick right now. Print program usage guide. So that's a good description right there. And then some other things you want to add. Required, this is not a required flag. Shared, I want this flag to be shared among subcommands too, because that just makes sense. Because I want this shared, I also want to know what subcommand called this flag, and the reason why I want to know that is so I can know which subcommand to print usage for. So I'm going to add a who wrote, and I'm going to pass in help parser, or help who wrote, rather, and I'm going to put this up here, and it's going to be a pointer to an APIC parser. And I'm just going to set it to null for now. And then I also, you rarely, if you have a command, like if you're typing a grep command, you may just want to, like, you don't know what else to add to this command, so you just want to type help, and you want the command to print help without validating any other flags you passed. And you can do that in APIC. You can basically terminate the parsing process and just do what the flag needs to do without any extra validation by simply saying do not care equals true. And what this will do is it will just it basically means if the user supplied the help flag to the command line program at runtime, it will basically say that that's fine, you don't need to validate any other data passed to the CLI program, and you can just process that help flag without any other processing of any other data, any other validating, etc. It's basically, it basically just tells the program to not care if anything else is wrong as long as this flag is supplied. And that's incredibly useful for stuff like this. And now we have this basic help flag, and we should always check, is there something else we might want to set? No, looks good. I can leave the rest to just 0 initialization. There's also a write notify flag that takes a boolean and it just sets it to true if the flag was specified. That's more useful for complex non-switch optional flags. You guys, if you want more examples, look at the repo. And the repo's tests directory, or test directory, has essentially self-documenting code. So if you want more information about this library, look at that. It's a useful resource. Now I also want to go down here, and I basically want to say if help, I want to figure out what executable argument to use. So this will be like, let me pull up one of my programs that uses this library, which is my to-do list application that I wrote in C. This here, it has this usage guide, and you'll see this total label. This is what I'm essentially going to set here, is what should I use for this first identifier. So the program name essentially, or the subcommand name. So I'm going to do, what do I want to do here? I want to do const APIC stir slice exec arg stir slice, and I'm going to, or rather, usage name, and I'm going to say if, I essentially want to say if help who wrote is equal to APIC parser, or the parser that I made, then I know that this is the root parser. So I want to say an APIC stir slice of the exec arg, and I want to get the length of the exec arg with strlen, so I need to include string.h. And what I want to do now is I want to put a placeholder here for, since I have no subcommands, I don't really have anything I can do here. So I'm just going to put an APIC stir slice literal here, and I'm going to say placeholder for subcommands, please update when has subcommands. And again, if you want information for what to put here when you have subcommands, then that's all talked about in the test directory in my APIC repository. Now I want to do APIC print usage, and I'm going to print usage to std out, and I'm going to do the usage name here for the run arg. Then I'm going to pass in the parser, which will be help who wrote, and then the style. So APIC lets you choose the style that you want to use for your parser. So for example, if you type in Linux commands, you'll be familiar with like A, B, hello, for example. But if you're coming from Windows, you might be familiar with A, B, hello. And this also extends to, like, for example, A, this is a flag, B, this is a flag, and then if you type this, now hello is an argument. So there's also this too, but in Windows it will be, I believe, this. And APIC lets you configure this really, really easily. And the way you do this is by creating a style struct. So how you do this is first you do const APIC style, and then like this. And then you define these values. So tick long will be a string, and I'll just do double ticks like that. Tick short will be another string like that, and tick, allow chains. So I want to allow chains, and what this does is, if you've ever done, like, for example, grep RNI to find text case insensitive in a directory with a bunch of files, this -RNI is not one flag. What this actually is a compressed version of -R for recursive, recursive in the directory you're in, -N for show line numbers, and -I for case insensitive. So you could type it like this, but most people just compress it down like this. This is a very common thing in Unix CLIs. So this is what that allow chains allows you to do, is just chain everything together with one tick, one short tick. And yeah, also if you provide a value, this value will go to the last flag in that chain, as you would expect. If you don't allow chains, then this chaining behavior is rejected by the parser. And what else do we have? We also have flag off. This is that previously discussed, like, --hello becomes an argument instead of a flag. So I'm going to set that to that. If you're on Windows, like, you'd set it to that. And then you want, what else? Flag value separator. Flag value sep. And this I'm just going to set to an equals. And what this is the parser is flexible enough to allow you to specify values as either in the same argument or a separate argument. So, like, for example, you could do hello John, or however you spell John, like this. But you could also do it like this in the same argument. And my parser supports this fully. And you can even, like, customize what this is. And there's also a flag value stupid mode. And what this is if this is true, then this will only accept this. If stupid mode is true, then this is not valid. Only this would be valid. You have to use flag value sep if the stupid mode is true. If it's false and flag value sep is false, then obviously only flag value sep is a null pointer, then obviously only this will be valid. So you have flexibility here. You can decide how you want to do things. I'm going to leave this off, though, because I want ultimate flexibility, and really the only time you use that is if you're, like, doing a rewrite of a different utility and you want compatibility between how it parsed arguments, and it use that kind of stupid force you to use flag value set pattern. So that's when you would want to use that. And once you have that style, you just pass it in here. And then you want to pass in an ANSI color to this implementation I wrote in the library. You can copy and paste this function and write your own implementation too. I might extend this implementation in the future to allow more flexibility. But yeah, so for the ANSI color, I'm just going to do a nice blue, which is a 4. And you can look up ANSI colors online to figure out what to use. So like here's 0, 1, 2, 3, 4, 5, 6, and 7. I'm using 4, so this nice blue. And yeah, so that's printing usage. I'm also going to exit 0 here, or exit success rather, and success because I used the help flag. Failure if you print this usage but without a flag explicitly telling you to. So yeah, and then I want to parse this. So what I'm going to do is I'm going to say above this help flag, because obviously you won't be able to check this unless you parse it. So under this end debug stuff, I'm going to do const APIC parser result. Parse result is equal to APIC parse. And I just want to pass in the parser and a state. And this is a state used by APIC and the subcommands to, like, for example, turn off flag parsing, stuff like that. I also want to create a token stream. So I'm going to do that above here. I'm going to say APIC global parser state. State equals APIC global parser state. And then I'm going to create a token string. So APIC token stream is equal to APIC token stream, and it's going to take in the style, the argument count, and the argument array. So I'm going to pass in style, argc, and argv. And this is the token stream created. And it's a lazy token stream, so it doesn't, like when you do this, it doesn't just evaluate all the arguments and turn them into tokens, it does it lazily. So you want to make sure that like this lives long enough, which it should if you're all doing this in the same function. So now I'm going to parse this, and what I'm going to say is if parse result is sum, meaning there's an error, I'm going to say const APIC parse error, and I'm going to say parse result sum. And notice how this is parse error and this is parser result. This is parse error, this is parser result. And what I'm going to say is I'm going to say fprintf error. And actually, what I'm going to do here is, so std error, since this is error, and I'm going to say if error arg index is not equal to APIC parse error no index. So if there is an error index for this error, I'm going to print out the argument at that index. So I'm going to say fprintf std error, and I'm going to say space open paren close paren, I'm going to say space open paren close paren. I'm going to put a string substitution in there. I'm going to say argv, can't type today, argv error arg index. And this is completely safe. The parser is not going to generate invalid indexes or indices. So as long as you put it under this check, it should be fine. And what I'm going to do after this is I'm just going to print a colon. So like this. And I'm also going to print the error here. So error dot type. And what I have to do is APIC parse error type to cster. So error.type. And this will print any errors encountered during parsing. And I also want to exit failure here. So exit failure. And then what I'm going to do is if this succeeds and all the data up here is set, like help will be true if help was specified, etc. So now what I'm going to do is I'm going to check help after parsing, and yes, so let's test this so far. So I also got to args parse, I got to put the parsing down here, so I'm going to say const args parse, and I'm going to pass in argc argv, just like this. Now if I compile this, so let me show you the compilation process. So I'm going to do I'll just do CLI, main.c. And then I hit enter, and now it's compiled. So if I run CLI, you'll see there is, oh, right. Okay, so I made a little bit of a mistake in my code. The runtime parser validity might actually be valid. So what you want to do is, if VD is not equal to APIC parser VD OK. So you want to wrap this code in this check. My bad, I missed that. So now I'm going to recompile, and I'm going to run it. And you'll see that it succeeds. And if I pass in -- help, then it prints out the usage. If I add some subcommands or arguments here, it also print those too. It prints the description, it prints whether or not it's optional. I can also pass in the short flag version, and it works. So now I need to implement these two. So what I need to do is strings get a little hairy, but it's manageable. So first off, I'm going to create another Boolean here for colored, set it to false by default. And what I'm going to do is I'm going to put up here APIC flag value target flag value target colored. And this will be another switch. So flag value target switch colored. And I'll put right here APIC flag target and flag value target colored. And here's those curly braces. And I'm just going to put name long will be colored, or I need to make it a stir slice. APIC stir slice literal. I need a name short. Short will be a single character. I'll just do C. I can also do a capital C if I want to as well, by the way. Description, APIC stir slice literal. And a capital C and a lowercase won't collide if you do those for separate flags, by the way. And I'll just say print message with color. And then what else? So this is not a required flag since it's a switch flag. The parser may do weird stuff if you say required and switch. So just avoid this required field. Avoid this required field if you're making a switch flag. So yeah. And okay, so name long description shared. Why not? Let's make this flag shared among all subcommands too. Who wrote, write, notify, required, name. So, okay, this looks good. This flag is now configured, it's done. So yeah, and we also need the message. So how we're going to do this is first we need to create a stir slice. APIC stir slice message stir slice. And I'm going to set this to a 0 initialized struct, so it's a null pointer and a 0 length. And what I'm going to do is I'm going to create another target here. So I'm going to say APIC flag value target message. I'm going to say APIC flag value target non-switch this time, and this is because it actually takes data. And I'm going to pass in that data. So flag value target, or I'm going to say flag parse pointer message, and I'll define that up here. APIC parse pointer flag parse pointer message, and I'll say APIC parse pointer. And the way you're going to do this is first you want to say how you want it to be parsed. So I'm going to do a stir slice, and I'm going to pass in message stir slice here. And there's other things here too. Like for example, there's a uint32t, for example, and int32t, whatnot. And it's all supported. All the integer types in C are supported in stdint up to 64 bits. If 128-bit integers become a thing, then I'll add it in here too. So yeah. And okay, so now I want to add this flag down here. So I'm going to put it here, and I'm going to say APIC flag target flag value target message. And I'm going to put in these curly braces the definition of the flag, name long will be an APIC stir slice literal with message, name short will be M, description will be an APIC stir slice literal, message to be printed, and then this flag is required, it's shared, and yeah, I think that's about all. So the parser will error out if this flag is not specified in the command line arguments at runtime. So yeah, and then what I'm gonna do here is after parsing, what I'm going to do is if this help is not triggered, I'm gonna go down here, and this is where I'm gonna write stuff to args. And I'm just gonna put in these braces to make it clear. Write data into the arguments structure before returning. And I'm going to say args.message, or first I'm going to create a static buffer. Static char message cstir buffer. And I'm going to say 1024 bytes. There's smarter ways to do this. They're just more manual, and for the sakes of a tutorial, it's fine. Args message equals APIC stir slice to cstir. And I want to do, actually think I have to do message cstir buffer. And above here, I'm going to do APIC stir slice to cstir. I want to pass in the buffer, of course, the length of the buffer, and the message stir slice. And this will write that to this buffer, and then I'm putting it in args. I also want to write colored to args, so I'll do that down here. And yeah, so now that should be everything for parsing the arguments. And then in main, what I'll say is I'll have the message. So if args colored, I'll just put some code here, which is going to color the text. So 033, what color do I want to make it? I'll make it magenta, bright magenta, because why not? And then I'll also say, so when you write colored text to the terminal, you also want to reset the color, and that's what I'm doing down here with 0330M to reset the color back to the normal foreground color. And then I'll also just print the message. So I'm going to say string substitution and a new line, and I'm going to say args message. Now if I run this, so first I need to compile it, and then if I run this, you'll see that error missing one or more required flags, and since it's a no index error, there is no data on where this error occurred. So now what I'm going to do is I'm going to specify the message flag, hello world, and you'll see that the message got printed. And if I then specify the colored flag, or -C for short, now the flag is colored. So yeah, that's kind of the entire tutorial done. If you have any questions, I also have a Discord server, which will be linked down below, probably on my website, since I like to link people to my website since I can update links there independently of other sources. So I might link you guys to my website for my Discord server. Join that if you have any questions. You can also send me an email. I think I flashed my email address somewhere in the video that you can get a hold of me. I also have it on my website. And if you have like subtle questions that you want to answer yourself, or you want to find out more about how this library works, I've also got this tests directory here, and it goes over a lot of the stuff that I did not talk about, and it's pretty in-depth too, obviously, because it's a test code that I wrote. So yeah. And I will have all the links down in the description, so the link to the repository, etc. And I hope you guys enjoyed. Keep programming, build some cool stuff in C, and I'll see you guys next time. Bye-bye. See what I did there?